Hello, ladies and gentlemen, and welcome to our conversation on the sulfur cycle. Now, at this point, hopefully you have had the opportunity to watch the video on the sulfur cycle and have added it into your notes. I just want to quickly touch on the picture that's in front of us. This came from your textbook, and it's a little bit confusing. But what I want to talk about is, again, this idea that we are going to talk about the fast cycles and slow cycles of these biogeochemical cycles that are really important to life on Earth. So, like water, carbon dioxide, and oxygen, sulfur too is cycling through the lithosphere, hydrosphere, and atmosphere. So, reminding you, lithosphere means anything on land, hydro in water, and atmosphere up here is the sky. Now, like the carbon cycle, sulfur has a fast cycle and it falls through the atmosphere. Okay. So what happens is sulfur is naturally occurring and will get mixed in with condensation as clouds form. It'll get into that precipitation and it'll fall down to Earth. So it's actually natural for us to have acid rain. The not natural side is how much sulfur dioxide we as humans make, but I'll get to that in a minute. The fast side of sulfur essentially is you have sulfur in the atmosphere, and due to, like I said, the mixing in with water, it becomes acid precipitation and falls both on water and on land. Now, the fast cycle here shows then how we can take it and make it from hydrogen sulfide, which is essentially something we can't use at all, and it takes bacteria that are found in the soil and ends up making it into sulfates. Once you have acid rain falling down, changing from hydrogen sulfide into sulfate, that can be taken up by the plants. And the plants then can use it, they'll decompose and put it back into the ground. But the interesting part is when plants are using it, animals that eat plants will get sulfur in their diet, and then we eat those animals, and then we get sulfur into our diet. So that's kind of the fast part of this one here. The atmosphere with the acid rain falling on the ground, changing up to the sulfates, plants taking it up, okay? And then we can actually get sulfate into our diet. Another way is just through evaporation. Once again, much like carbon dioxide. The rain falls, evaporates up, and we get sulfur back in. The other part to the story is the slow cycle of sulfur, which I find also quite interesting. And then there's the sulfur cycle in water. So the slow cycle for sulfur, okay, has to do with deposition again, the idea of sedimentation. But this time, in order to get sulfur to actually come up, we need some sort of geological uplifting, moving of tectonic plates. We need volcanoes to erupt. We need groundwater to shift and move the actual soil around it. And mining and fossil fuels is a big one. But most of all the sulfur is going to be kept deep in the ground. You can mine for sulfur. It's found in iron sulfide rocks, coal, ore, and oils. And so in order to get sulfur out of the slow cycle, you need one of these to happen. Now, one of the most unique things about sulfur, much like the carbon dioxide cycle, is that you can find sulfur on the floors of the ocean in seafloor vents. And the unique thing is there are bacteria that actually live there that produce sugars, much like how our body produces energy from the sugars. Okay, they make their sugars like photosynthesis, but instead use a process called chemosynthesis, in which they use chemicals such as carbon dioxide and hydrogen sulfide to create energy for themselves. Now, there's something really unique about Alberta that we're going to talk a little bit more about in human impacts, and that's the fact that we have very alkaline soil in Alberta, which is a really big benefit for us because alkaline essentially means base. And what ends up happening is when we get acid rain falling in Alberta, our soil naturally neutralizes the effect of that acid deposition. So we might not see as severe of effects on ecosystems, on landmarks, on things like that due to acid rain because of the nature of our soil. So again, slow cycle on this side, kind of going through this way. I'm sorry, that's fast cycle. Slow cycle down here, and the unique part with chemosynthesis, and we'll come back to that. So all organisms require sulfur because it's important to build for proteins. If you remember CHONPS, proteins have sulfur in them, and vitamins. And vitamins are really important because we have to eat them to get them. We don't make most vitamins in our body, so we have to eat them to get them. And then we have to eat them in the form of something called a sulfate. We don't want to have sulfur and the hydrogen sulfide or sulfuric acid forms, obviously, we want to make sure that they are changed over to something called a sulfate, SO42 negative. That's done through something called bacteria, and bacteria in the soil actually have different roles in the sulfur cycle. One will convert sulfates to sulfides, others will convert sulfur oxidizers into sulfides and make elemental sulfurs or then make sulfates. It really depends on the bacteria, okay? And it really changes up how we eventually get sulfur into the edible form, or the usable form, I should say, of sulfate. So the big role here you have to understand is in the ground and in the oceans, or in other big vents like think a what are those called? I'm trying to think, like geysers, okay? Though that's what I'm trying to think of. They're going to have some sort of sulfur there, but in order for anything to use it, we need to turn it into the form of sulfate. So some of the highlights about the sulfur cycle is that it highly reacts with water vapor in the atmosphere and forms sulfurous acid and sulfuric acid. And this is what causes acid rain or acid snow or acid sleet. Okay. It's also the way that sulfur gets returned back to our oceans and soils. So naturally, this cycle occurring is a good thing because it actually brings sulfur back into our soils, back to the oceans, because normally sulfur likes to hang out up in the air. And just because we take a deep breath in doesn't mean we're using sulfur. It only goes into our lungs. We need to eat it to use it. In order to get a lot of the sulfur that is in the slow cycle, okay, it's really trapped deep down in rocks. So volcanic activity is actually one of the most common ways for us to see released sulfur in the air, okay? And then it gets released into the form of sulfur dioxide. So again, the one that reacts highly with water. We also have the rapid cycling, which I talked about, atmosphere on all that stuff, but essentially we can take it out of there and with different bacteria. So some bacteria converts it to sulfates, but other bacteria will actually create sediments that become part of rocks, so sedimentary rock, which then eventually leads to fossil fuels, which is oil, coal, and natural gas. They all contain sulfur. So that's, again, the slow side of the sulfur cycle. So what you have to remember is the impact we have upon the sulfur cycle. The amount of sulfur that is released in the atmosphere because of human activities is greater than the natural processes. So burning of fossil fuels, mining to get sulfur out of the ground, burning oils, coals, natural gases, I already said those things, okay? All of that creates more release of sulfur into the atmosphere, which is way more than it naturally needs. That is why acid rain over the years has become extremely, extremely dangerous to lots of ecosystems and their biomes. It's essentially because it's becoming more and more prevalent. You see it in a lot more places. It's becoming stronger, and places with higher and higher pollution rates, okay, we'll see a lot higher and higher acid rain. But the issue is wind blows pollution everywhere. So just because you live in one area with pollution doesn't mean that you're not going to see acid rain somewhere else popping up. And that's because those pollutants can travel far and wide. So that's why we have different organizations that come together around the world that try to reduce carbon emissions, sulfur emissions, and all those things. Because what we're trying to do is remind ourselves that just because one area is highly polluted doesn't mean that it doesn't affect other areas. So you do not have anywhere in your notes to write this, so please just find space to put it. But essentially what you see here in a picture is the process of chemosynthesis. So the seafloor has these hydrothermal vents, really hot vents, okay? And they release a large amount of carbon dioxide and hydrogen sulfide along with water. Now, the unique thing is bacteria over time have evolved to be able to use that carbon dioxide and hydrogen sulfide and actually make it into sugars and then other sulfur-like compounds. So we can see these bacteria using these different hydrothermal vents to actually make themselves energy. That process is called chemosynthesis, okay? Or we call these organisms chemosynthetic organisms. Essentially, again, they're just making energy by using chemicals rather than using the sunlight. Our knowledge of chemosynthetic organisms actually is fairly new. We didn't start really exploring the ocean floor until 1977. And when they did, they were able to see thriving communities along the bottom of the ocean around these hydrothermal vents. Once they noticed these, they started to look other places, and it turns out they're there in hot springs and on seafloors around the thermal vents, in cold seeps, and even in whale carcasses and sunken ships. You can find these types of things, these chemosynthetic organisms or communities, quite in some unique places. But again, they're cool because they're using the dissolved carbon dioxide and the hydrogen sulfide that is being deposited into the ocean, and they're utilizing it to create energy. So that's it for the sulfur cycle. So please make sure your notes are up to date. You know what chemosynthesis is. You have an idea of what the key player is to convert sulfur, again, that bacteria, and knowing again that sulfate is the edible form of sulfur, the one that we use. And last but not least is that naturally sulfuric acid and sulfurous acid, all right, happen to be in our atmosphere. And naturally, it's not a bad thing, but due to human just regular everyday life on our planet, we've actually added way more into the system that's needed. So please make sure those are the things you've taken away, and I will talk to you later.